Hello everyone. In this video, we'll be looking at visualization in Python. So let's get started. So in Excel, visualization was really simple. Just go to select data, go to the charts and select what you want. So that's one easy way of visualizing it, but Excel doesn't allow us the flexibility of handling data and processing as in Python. However, Python does have some a little bit more steps necessary to put data into a single data format and then put it into the libraries that handles the visualization. But once we get used to that, it's actually quite straightforward from there. So what we're going to do is start off with Matplotlib. You can find matplotlib.org about its details, but basically this library is one of the most widely used graphical tool for Python. It can be used on multi-platforms, so it doesn't matter whether you're using Windows machines, Mac, or Linux. Matplotlib will work on all those platforms for you. And it does produce really good quality graphs as well. So those are really good. And it provides extreme flexibility in terms of how you can control the way it gets displayed. But using this flexibility is not a trivial thing to do. However, we're not going to be too worried about making things super nice, but rather we just want you to learn how to collect data and chuck it onto Matplotlib and visualize the data as is. Okay, so here's an example program to get started. So what you can do is just copy and paste into Python. This is multiple pages. Okay, and what we're going to use is this rain.txt file. Okay, this just to give you an idea what visualization in Python looks like. So this is rainfall stuff from our file stuff, but I have shortened the file so it doesn't have a whole lot of stuff because it's too big to display at one go. So if we look at our code, so you should be familiar with these formats. Basically, we're extracting our rainfall data from a file, but essentially what we're doing is all the things on this page is rainfall data handling, and then we go to plot rainfalls, and this is where we start to do some plotting. Basically, we're getting our data set, determine how wide our x-axis width is, and then just chuck all the numbers and do some formatting, and then it's going to produce a graph that looks like this. Okay, so let's have a quick look. So if we do this and run it, then what it does is it's going to create a chart for us, and hopefully without editing anything, you should see the exact same chart that has been created into the screenshot. So we can quickly see, rather than looking through the data, although we can highlight, say, like a max values and min values through pandas, but this gives us a better view about how the data has been distributed, right? So visualization has many benefits to understand data. And I did format this nicely, so by default, this will be all clunked together, but we see that this has been skipped and so forth. So we're going to learn all about how to create charts like this from raw data from here. So let's get started. So plotting with Matplotlib is actually easier than you think. So what we do is first, you have series of data. So these data can come from, say, your NumPy or even Python list, or just extracting data straight from file. And then you chuck it as a kind of like a list data structure and put it into plot. Okay, so matplotlib.pyplot, you import that as plt, pyplot. And then we just chuck in our series of numbers. Then it knows that these are going to be our points along these are the y points for each x value that we're going to use, right? And we can add some labels like some number, like here for y-axis, and then just do plt.show. So let's do that. So let's hide this guy. Okay, so plt. So even just 2 lines, we can draw charts. So we have this import at the top. So we run this. Then what we're going to end up with is just 1, 2, 3, 4. 1 at the 0th index, 2 at index 1, 3, and 4 at index 3, right? So we can quickly draw charts easily. We can even mix these numbers up, like say 10, 13, 41, and draw this again. Okay, then we're going to see some like a funny zigzag looking one like this. But you know, plotting is very easy, and we can easily add labels using plt.y label, plt.x label, and so forth. Right? So that should be clear as in how easy it is to plot values and get a chart out of it. And from the data set we used in the previous video, we can plot that as well. Okay, so we can now hide these guys. What have I done? Hide these guys. Okay, and normally you will call plt.show to display, but if you don't show it, and by end of the code, it's going to try to show it. Okay, so we can just go plt.plot, and what df.datascience do is df has been loaded before. It contains values. Okay, and this contains 2 columns. So what it does is use the first column as x values and second column as y values. Okay, and it has some the data types, but plt the matplotlib.pyplot understands how to interact with the pandas data type, so this is very useful to do. Okay, so rather than just data science, we can put something other thing like machine learning. We had machine learning before, but if you're unsure, please go and watch the previous video, and they kind of had a similar style, but essentially we can graph them pretty easily. Just chuck in the numbers into the plt.plot and it's going to show us the result. Okay, so hopefully that shouldn't be too scary thing for you to do. So next, what we're going to do is add a bit more data stuff, right? We can specify both x and corresponding y values. So again, this one, in this case, we're starting from 1 up to 4 for x values and 1, 4, 9, 16 for y values. So these are just squared values, right? Then we can quickly graph something like this, 1 at 1, and then it's going up all the way to 16. Okay. Hello. Not responding. Okay, that's fine. So we can always change these guys, 6, 13, something like this, and run it. Then what it's going to do is do some funny stuff like this. 1 at 1, but at 6 it's going to be 4. Okay, and at 4 it's going to be 16, and then at 13 it's going to be 9, right? And it's trying to connect them as the numbers appear in y-axis. Okay, so if you mix up the x-axis, it's going to follow the y-axis values like this. So if we now order these guys, so here 4, 6, 13, and then the 16 value come here. Then if we run this now, then now it's going to, the line's gonna go that way, going up and down, right? So remember that this line connection will follow the y values associated with, not the x values. Okay, put that back. Okay. And again, we can plot for our data sets that we had before. But instead of using the column numbers, which we had before, we're going to use our dates as part of the mess column was the date column. So we run this, then, oh, wait, I want to not show this. If you have two graphs plotting, then it's going to show you two lines together. So we don't want that. So let's do that again. Basically what happened was it plots both lines, but we're going to show that next. Okay. So here is the result. Instead of having little numbers, now we have actually values, but we haven't formatted how the x-axis label gets shown. So that's why these are all cramped because they're all displayed horizontally. So, but if we zoom in far enough, we can see that individual date points are like this. Okay, but since we have so many points running through, there are 200 points that we plotted. They're all crammed here like this. So we're going to see how to fix this soon enough. Okay. So we can easily specify the x values associated with the y values by either putting in two lists of values into the plot. Okay. So now we can also plot multiple graphs that we have seen just before glimpsely. Basically, they come in as x value, y value pairs of lists. So if we have 2 times 2 rows, then the second values will be treated as the second series. Okay, so let's do that. So here it is. And in here, what we're doing is adding some bit more details. For example, we're adding the Y label, the X label. We're even going to add some legends to see which line represents which, title of the graph, and so forth. So if we run this one, yoink, we'll get the same graph as what we have here. Okay, so here line 1, the first input will correspond to our first line that we plotted, second one. So remember, legend will take in a list which describes what they are. Okay, and then finally we can add some details and then show which line corresponds to which one. Alternatively, you can plot multiple lines before displaying the chart. So basically what we did was, not that one, hide this. What we did was, here we use one plot, but you can use multiple plots. And what they're going to do is, until you show it, it's going to accumulate all of those data onto the single output file. So by plotting multiple times, I'm going to use the same x values, then we can put all those lines together. And Matploti by default will try to put nice colors for us if we don't specify them. But we later we'll see how to specify those as well. Okay, which is now actually. So as we've seen, it will give us a default color, but sometimes you want to use some specific color, especially if you have like multiple variables. So you can specify exactly what color you want. So Matplotlib understands that yeah. Here, we're going to use this example again. It understands that if it doesn't get a list on as a consecutive, but some command that it understands, that it's going to treat it as the command to control the line. So for this instance, we want to specify green and red for our first and second line. So we're going to keep our legends and stuff. Then if we run this, then what we get is our first line being green and our second line being red. So we can easily change our colors. And if you want to look at which colors are available, we need to look at the plot help. Okay, so we can do plt help. plt.plot. Okay, so here is some format string like blue, red, green, things like this. But there are some other markers that we can use. Here is the colors, full color list: blue, green, red, cyan, and so forth, right? And there are some other markers which we will cover after this as well. Okay. So the markers are to specify the points that we want to chart, right? So in this one, we have 4 points. To show that, we can add some markers to show this. Okay, and by looking at plot help, there are different marker options. So there's actually quite a lot of those, which explains which one refers to this. Okay, and what you need to do is just chuck in together inside as a string. So for instance, if we want to use a circle marker, then it's going to pass in O, letter O. If we want solid line, it's just 1 dash. If we want dashed line, is dash dash, and so forth. So here, rather than just green, we can put X as our marker, and our red line is going to be a solid line. So here, this one is dash X. So if you run this, we're going to get this graph as we've seen here. So our line 1 has been placed with marker X, which is of color green. Line 2 is red color, which is a solid line. Okay. So if we look at the help plot again we can use some other like styles. So let's change to line dot. Okay, and maybe X with dotted line, and then we can run this. And you can easily see that it has now updated. So line dot was line 2, and then a dotted line was used for line 1. So we can easily change how those graphs are represented. Okay, and we probably want to do that. For example, if we calculate some interpolated points, then we might want to use the dotted line rather than solids, and maybe solid line for our actual data set files. Okay, so we can easily change these values as necessary, and if you get stuck with how to display them, you can always look up the help of pyplot plot. Okay, all right. So now let's look at graphing loops. So as we mentioned before, all we need to prepare for visualization is the data set and potentially its corresponding X values, right? So what we're going to do is this time trying to plot some equations. For instance, plot sine x and only the positive values of 2 times the sine x, right? So from 0 to 4 pi values of x. So that's what we're trying to do. So we're going to use our math module and import this. Okay, so let's do that. Hide this. Okay, so I chuck it into a function called looping. And what we do is start x value from 0, and we're going to go up by increment of 0.05. Okay, and while x is less than 4 pi, so that was our terminating condition. Then what we can do is plot value x, y with red dot. So that's going to be our red dotted points. So obviously you can change the line style and color as well. But let's just run this and see what we get. Okay, so we should get exactly the same graph as what we anticipated. Okay, this red looks a little bit faded. Nevertheless, yeah, so essentially we wanted to plot only the values that are greater than 0 for our 2 times the sine value, right? So here this is the continue where we skip it, and then plot the other guy, which is y times 2. So this gives us 2 times sine x, which was plotted with green. Okay, so what this does is using our previous fact that if you just keep plotting values onto keep plotting values before you show, then it's going to accumulate onto a single graph, right? So after first initial run, we have dot dot, but we haven't shown, so it's going to be keep adding these dots until we finish and until we show. Okay, so this is an easy way of just looping through. So essentially, plotting using loop is just to accumulate the number of points you want to add into the chart. Okay, so hopefully that shouldn't be too difficult. Okay, so as we've seen before, we can add legends, but sometimes you want to label the lines rather than trying to hard code those labels that we have seen before. So for instance, in this example, we have added legends by ourselves, saying that's line 1 and line 2, but sometimes if you are plotting different lines at different locations, remembering which line has which legend can be confusing. So instead of doing that, what we can do is add labels to each line. So by adding this label, say for example, this was data science, I don't have to worry about manually assigning the legend value for it. Then once we have all those labels, then all we need to do is plt.legend, and this is going to look for the labels associated with each line and then show that for us. So if we run this now, we get our legend that gets populated, so essentially this one, from our labels. Okay, so the label data gets populated into the legend. So in this way, rather than passing in a list of actual label values, we're going to directly retrieve the labels from each line. That means I don't have to get confused if I am graphing different lines at different places. Okay, the remaining stuff should be familiar to you, just doing labeling X and Y and adding some title. Okay, so adding legend is quite straightforward. Just add some labels and call plt.legend. So before, what we've seen here, well, still here, is that our x-axis is very cramped, right? It's not really showing us any useful information. So what we want to do is fix this x-axis. If it's cramped, then what we want to do is just select a few points to represent roughly how far we are at. Okay, and we can we can modify this by using the xticks. Okay, and basically what this xticks method do is define how many points should be displayed as part of the chart. Okay, so this can limit the number of points to be displayed. This one got cut, but you will have this code to play around with, so don't worry. Okay, so what I did was first it takes a range. Okay, so if you look at, let's have a look here, help plt.xticks. Okay, then if you look at its arguments, it look for ticks and then labels and whatever else you pass it in. Okay, so basically the ticks are like array-like. So here the range will produce an array-like items. Basically, it's the list of positions at which ticks should be placed. So this way, we can determine at which points we're going to display. So what I did was start from 0 up to the very last item, length of this, but I'm specifying the skips, okay? And my skip has been specified as my whole item divided by 24. So I'm skipping every 24 items here. Okay, and my second argument is our actual the X label that we want to add. So this is our pass in. And after this, I don't have to pass in any more variable. I can close it. But since our X label value is actually quite long, what I want to do is rotate it 90 degrees. So it sits sideways. So I can always add rotation of 90. If you wanted to look the other way, you can put 270, or if you want it diagonal, 45, and so forth. Okay, So once we have this, we can run this. And what we end up with is much more readable x-axis values, because now it's skipping yeah, at those intervals, right? So it has skipped nicely by adding 24 into these ranges. So you can always change this, say, for example, maybe not 24, I want bigger gap, so maybe 48, for instance. Then what I end up with is, sorry, if I divide it by 48, I get less skip, so I have twice the more numbers, right? So I get more cramped dates. And if I want less numbers, so maybe if I go down to 12, then my skip is going to be much bigger, like this. So I have much less numbers. Okay, and eventually, if your skip gets larger and larger, you have less X labels. So this will depend on how many X points you would like to show depending on your data set. So you can determine this yourself. Okay, and also another one is this tight layout. What this tight layout do is, if I don't have this, what it's going to do is the axis, the 90-degree line, it has its fixed location, and if our x-axis label is too large, it's going to push things outside the bound. So this is what I mean. So usually it has space for this much, that's by default, and it's probably expecting some number and enough space for label. But since I have rotated our label, it has pushed down our x-axis label. The date is gone. So what it does is, if I call tight layout, what it means is it's going to find out the boundaries of this whole graph and trying to fit it inside my display area. But of course, you can always change this to stretch your data, but obviously this location has been fixed, so you want to always call the tight layout to make sure that everything fits inside the display that we have. And once we have that, what you can do is you can always navigate around or reset the view, but you can save this file. So once you save this, it tells you how you want to save it. It does provide you multiple options, but PNG is a good option. It keeps the data format, and then you can use that in other files as well. Okay, so next one is the subplot. Okay, subplot is to graph multiple items, multiple graphs in a single view. Okay, and subplot allows you to, basically it kind of act like a grid, and inside the grid you specify where those subplots should be located. Okay, so here row, column, and location is how we control subplots, but you can cover basic layouts more in these links here, but let's have a look at the example. Okay, so here is our subplot example 1, like this. Subplot example 1, basically I have all the inputs at the top, and what we're going to plot is some curves. So basically what it's doing is plotting sine and cosine in two different plots in a single figure. So that's what we're trying to do. So this one is the sine x, so we're using the numpy sine. Okay, have some spaces. Okay, and similar here, we are plotting cosine down here. And as you can see, the way we plot it is pretty much the same. Plot the value x, so this is our x label values, and this is our y values, so x and y values. Okay, so doing the NP gives you an array list, so we can automatically apply the sine x to all the numbers already. Okay, and then we add some labels and title, right? And this is one graph. But what we're doing is we command our PLT because we are doing the subplot, that we're going to have a subplot of 2, 1. Okay, so that means I have 2 rows and 1 column, and whatever the command I'm providing is going to go into the location 1, our first location. Okay, and our next plot is still 2, 1, and the position of it is 2, so it is our second slot. Okay, and this one basically doing the chart as well. Okay, and then what we're going to do at the end is call the type layout and then show the plot. So let's run this, and this should generate us the same chart that we see outside here. Okay, so as you can see, it generates the same chart. Basically, we're running from 0 to 10, so that's what we're doing. We can always change these values, skips of 0.1. So this way you can graph multiple charts, multiple graphs into a single display output. Okay, so subplotting is all about locating which chart goes where. Okay, so let's have a look at another example. So this one, what we're doing is just using some random numbers to generate these data. So your output results may look different to what we have here because we're just generating some random numbers. However, this also shows that we are not only plotting line charts, but we can plot some different charts as well. So let's just draw this first and go over each one. All right. Okay, so we have our chart here. So it's a little bit squished, right? But essentially what you do is before you save it, you can always stretch it out and then you press the save button, then it's going to save that particular view of your chart. Okay, so as you can see, our result, some of them is slightly different, okay, because we're dealing with random numbers. So what are we doing here? So this time we have 2, 3, is it row column? Oh, I have these numbers other way around. So if you look inside my demo code, it's 3, 2, right? So that's 3 rows and 2 columns. So if you are copying from here, please reverse it. Otherwise, you'll get 2 rows and 3 columns. But nevertheless, it should still work pretty much the same way. But just to keep that in mind, basically the location is starting from top left, and then it's going to go down. Which way does it go? Plot 2. So it goes zigzag like this, left to right, top to bottom. Okay. So position 1, 2, 3, 4, 5, 6. Okay, so we are familiar with our line chart. Basically, it just drew the line connecting from left to right. Our second one is also just line chart. We didn't specify what it is. Third one is a histogram. Okay, and if you just chuck in numbers, what it's going to do is by default, it's going to create the bins for you. Okay. But you can always specify what bin size you want. We'll have a look at that. Okay, and then we have another plot, which is a line chart, which has 400 numbers. Okay, and then we have a sine line chart. Okay, so it's the same line chart. And then finally, we have the scatter plot, which takes in 2 values, right? So this is going to be our x values, and this is going to be our y values, right? So this gives us a scatter shot of this, and then we put into type layout and then show. So as you can see, subplots are actually not that difficult compared to just making one. It's all about making sure which one you put where. Okay, so let's have a look at our third example. Get rid of this. Third example. Okay, our third example using our data set that we have loaded before. And let's have a look at the code here first before we move on. So basically what we want to do is create a histogram like this. And what we do is just pass in the values. Then it's going to put it in there for us. Okay. We also have a scatter graph chart, okay, which we use for data science. And then we have the other two line charts, okay. And what we did was, instead of doing the like what we did here before by doing the subplot and locations, you can also use the figures and axes from the returned value from subplot. So what you do is, here, rather than specifying the location of the subplot, you output that into your figures and axes. And what these axes do is allow you to select which location it belongs to. So we can go axes. 0, 0 means the top left corner. We start from there, and then x values goes, well, for you this way, but y value goes down way, positive, okay? So when I say axis of 0, 1, that's going to be our, in our 4x4 square, it's going to be our top, because it's 0, right, because it's 1. Okay, and in here, I want to put a scatter chart of values mapping from dates and data science values. Okay, so here we do plt.scatter. And then once we have once we have loaded data, we have to put, plot our axes inside our PLT. So we have to use the SCA method to load the data into the plot. So this way can be a little bit more cumbersome, but it allows you to control how you want to put different figures in different locations in another way. So if you can prefer this way if you want to, but this is also another way of visualizing which chart belongs to where. Okay, and of course you can modify how the X-ticks and other formatting works, and then you can move on to the next one. Okay, so here I have put 12, 24, and 36 to show the difference. So as this value gets larger, we have more values to plot, so it gets more crammed. Okay, so we have seen a few types of charts here, like the scatter here, or histogram like here, but there are a lot more types of charts actually. So you can have a look at these sample plots, or look at the full list of charts, and there is actually quite a lot of charts that you can draw, so you can quickly look through there to see what you can plot. Okay, well, so that's kind of a basic introduction to Matplotlib. So hopefully now we can easily collect data and chuck it into our Matplotlib to draw some good looking charts. There are some other libraries that allows you to do some different styles of visualization, because Matplotlib is just one of the libraries, but it is one of the most widely used one. Some of the other ones that you might like to look up are Seaborn, Bokeh, Altair, Folium. This one is quite useful for interacting with the maps. Okay, so here are a couple of links for you to read further on if you would like to learn about some of the other libraries as well. Otherwise, this has extended quite long, so I'll stop here and I will see you in the next video. Bye bye.